Hello sir, my name is Mehul Prafulbhai Tak and today I will give introduction on data mining and visualization assessment component 2. Here are the topics which will be covered in this presentation. The first is introduction. The dataset contains 9,993 rows and 17 columns representing transactional data from a retail superstore. It includes discount sales, ordering time, customer group, delivery time, and product categories, so it is of great assist in business analysis. The dataset contains different regions which can be analyzed for market trends and business to business sales. The dataset includes discount and profits which can help in analyzing discounting on profits and revenues. By examining these factors, the order date, ship date, and product categories, businesses can balance delivery time and inventory levels. The second is aim and objectives. So the aim is to build predictive models on Veka from decision trees and random forest to predictive profit based on the given dataset. The objectives are evaluate the comparisons of both models with the use of standardized evaluation metrics such as MAE, MSE, RMSE, and R squared. Analyze the model output and draw an uh, understanding on corresponding features in predicted profit. Identify seasonal patterns and trends from the historical data that is likely to affect a future profit forecast. Examine the interaction effects between the above variables and non-linearity that underline their effects on profit margins. The next step is dataset overview. So source of the dataset is Kaggle. The size of the dataset is 9,993 rows and 17 attributes. Type of the file is ARFF. The software tool is Veka. Key features or columns and their relevance to the business problems are listed here. So here is the dataset table where the first column is column name, the second is column type, its description and example value. The next step is data pre-processing. First is normalization. Numerical features were scaled with minimum and maximum normalization to weight all variables equally when entered models. Categorical encoding. Notably, one hot encoding was used on categorical variables such as category and subcategory. Then test splitting. The dataset was split into 80% of training and 20% for testing. Outlier treatment. Outliers were detected and treated following interquartile range method rules for evaluation by means of application. Feature selection. Recursive feature elimination with cross-validation was used to find the best fitting subset of predictions weight model complexity against predictive performance. EDA process. So the first classifier is decision tree. Decision tree are one of the non-linear predictive modeling techniques to split data into branches for making predictions. The second is random forest. Random forests are an ensemble learning method for building and aggregating many decision trees together to make predictions. The implementation steps. So these are the steps which will be used to implement these models. And here is the visual graph of regional classification using decision tree. So as we can see here, so in this model there are total 9,993 instances where 6,050 instances were identified correctly and classified correctly, and the 3,949 classifiers were classified incorrectly. And this is and in a west region, its classification is 3,203, and the south region has 102. This is the classification, region classification using random forest. So here correctly classified instances are 9,259, which is greater than the decision tree classifiers, and incorrectly classified instances are 734. And as you can see here, the accuracy of this model is 92%, and the confusion matrix shows here where the west classification value is 3,133 and the south value is 73. Evaluation matrix. Here is the comparison of these two models. So the correctly classified instances are 6,050, and for the random forest is 9,259. And as you can see here in this table, this is the basic difference between decision tree and random forest, where the random forest is better than decision tree in some cases. Here is the key insights. Pricing strategy. Discounting needs to be reconsidered based on the evidence from models. Inventory management. Select the high margin categories that were identified by the models in VECA. Improving shipping. The faster they can deliver, the more customer profit and faster up. Customer segmentation. The output from the model should lead to marketing campaigns geared toward high value customers. And product bundles strategy. Create bundles that encourage bulk purchase by raising the average transaction value. Next is conclusion. The analysis delineates the significant advantages of profiting forecasting through the decision trees and random forest modeling of retail operations in VECA. The predictive powers measure very high for both models as shown by the good accuracy measures. The random forest slightly beats the other regarding generation and resistance to overfittings on different cases. As I said earlier, the strengths of VECA as the modeling platform allowed smooth model development with interpretable outputs that readily identify the result recommendations as clear actions for the business. The decision tree model opens pathways of business understanding that emphasizes key decision points for profit, and the random forest, being an ensemble method, captured complex nonlinear relationship between the features for better predictive performance. Here are the references which I have used in this presentation. Thank you.